Hello everyone. Now in this lecture we'll discuss about the stepper motor. The configuration of another important motor is shown over here. Normally a stepper motor has application where torque loads are relatively low. The application of a stepper motor in an engine ideal speed control system. In most cases the stepper motor output employs a reduction gear system in which the gear output shaft rotates at only a fraction of the stepper motor output shaft. The stepper motor of the configuration depicted in the above figure has excitation current IA and IB that are sequences of non-overlapping pulses. The relative phasing of the pulses determine the direction of motor rotation. The motor rotates a fixed angular increment for each pair of pulses IA and IB. Very precise angular position control is obtained for a stepper motor by the number and relative phasing of pairs of such pulses. A control system can advance the load placed on the stepper motor gear system by a specified amount through the number of output pulses sent to the motor. The speed of motion of the output shaft is proportional to the pulse frequency of the sequences of pulses on IA and IB. However, any such stepper motor has an upper bound on this speed such that the driving pulses are non-overlapping in time. Now we'll discuss about automotive engine control actuators. In addition to the set of sensors, electronic engine control is critically dependent on a set of actuators. These actuators allow to control the air-fuel ratio, ignition, and exhaust gas reduction. In general, an actuator is a device that receives an electrical output and produces an output of a different physical form. Example of actuators include various types of electric motors like we have discussed earlier, brushless DC motor and stepper motor, and there can be solenoids and piezoelectric force generators. In automotive electronic systems, the solenoid is a very commonly used device because it is relatively simple in operation and inexpensive. The solenoid is used in applications ranging from precise fuel control to the other applications such as electric door locks. A solenoid is a powerful electromagnet having a configuration generally similar to that illustrated over here in this diagram. Here you can see a spring, a movable element. These are non-magnetic sleeve. This is a ferromagnetic shell, and this shell has n number of turn coils, and this is the center post. X is the distance between this movable element and the center post. The solenoid consists of a fixed cylindrical steel frame with a movable steel element. A coil having n number of turns is wound around the steel frame, forming a powerful electromagnet. The source of the magnetic field in the solenoid is the current I that flows through the coil. The lines of constant magnetic flux density B form closed contour, which is denoted over here by a symbol C1. So in the upcoming lecture we'll discuss about that how solenoid is helpful for the fuel injection system. So in the fuel injection system, a fuel injector is a solenoid operated valve. The valve opens or closes to permit or block fuel flow to the engine. In this diagram you can see that there is a ferromagnetic shell, there is a center post, there is a spring. Along with the spring, a pintle is joined over here. This is the nozzle and this is the inlet of fuel. the fuel can go in through this passage. These are the non-magnetic sleeves, and there is an input terminal voltage which allow the current I to flow through this n number of coils. The valve is attached to the movable element of the solenoid and is switched by the solenoid activation. Consider an idealized fuel injector as shown, which the injector is open when the applied voltage is on and closed when the applied voltage is off. In this configuration, a solenoid has a movable element in the form of a pintle with a conical tip that fits into a conical section forming a nozzle. A spring holds this pintle such that the nozzle is closed. Behind this nozzle is a small fuel-filled chamber holding fuel under pressure that is supplied by a tube known as the fuel rail with no control voltage. That means when the Vc is equals to 0, that means no current is flowing. The spring holds a pintle in a closed position such that no fuel flows through this nozzle. With a voltage of sufficient amplitude is applied, the solenoid pulls the pintle out of its seat and fuel flows through the nozzle into the intake system. Once the pintle is pulled fully toward the solenoid center post, the fuel flow rate through the nozzle is constant for a given regulated fuel pressure and nozzle geometry. Therefore, except for brief transient periods, the quantity of fuel injected into the air stream is proportional to the time the valve is open. The control current that operates the fuel injector is pulsed on and off to deliver precise quantities of fuel. Thank you.